Hello, my name is Peter Milton and I am the developer of TimeChainage. This video is part of a series where I show you some of the more advanced features of TimeChainage. Advanced doesn't necessarily mean difficult, and the feature we are looking at today is easy to use. TimeChainage has a learning curve creator tool, and we will look at what it does and how to use it. First of all, what is a learning curve? Well, it's a mathematical concept that graphically depicts how a process is improved over time due to learning and increased proficiency. For linear type activities such as tunnels, pipelines, roads and railways, the learning curve is an easy part of the process to measure and monitor, as it boils down to being just an increase in production rate. Production starts at a relatively slow rate and then increases at a variable rate until the full production rate is achieved, after which the rate is more or less constant. A number of factors determine the length and duration of the learning curve, including the experience and skills of the production team, including the site management, engineers and operatives, the initial effectiveness of support teams and services, and how quickly an efficient workflow can be established. In the construction industry, the learning curve can be a significant element in large or complex activities, so it is important to make allowance for it in your program and costs. The question is, what allowance do you make? Ideally, you want to have experience of similar tasks that have been undertaken previously, or else you break down the task into all of its main components and take a view on what may delay achieving the full planned production rate. TimeChainage cannot help you decide on the length and duration of your learning curve, but it can help you to include it in a TimeChainage chart. For this demonstration, I have already set up a project in TimeChainage with some calendars and a work breakdown structure. To access the Learning Curve tool, we go to the Tools menu and select Learning Curve Creator. As you can see, some default values have already been set and the corresponding learning curve is shown. Before we start, we need to have decided what our learning curve is to be in terms of its duration, its length, and what the full production rate is planned to be after the curve. For this demonstration, we will want a learning curve duration of 15 working days, a length of around 125 metres, and the full production rate after the curve will be 18 metres a day. There are two calculation methods in TimeChainage. One is a steady acceleration method, and the other is a variable acceleration method. The variable option gives us a bit more flexibility, as you will see. Let's start though with the steady acceleration method. As the name suggests, the algorithm uses a fixed acceleration throughout. First we enter a start chainage. To keep this example simple, we will use a value of 0, but it needs to be the location in your project where the activity commences. The end chainage will be automatically calculated. However, we do need to say what direction the activity is going in. If the chainage is to increase with progress, then use the default left to right option. If the chainage value decreases with progress, then use the right to left option. Next we enter the start production rate. Let's assume it will be 2 metres per day to start with. We then put in the end production rate, and this will be 18 metres per day. As you can see, the chart is updated each time we enter some data. Finally, we enter the duration, which we have determined to be 15 days. Bear in mind this duration is working days. You do not need to worry about weekends or holiday periods, that will be taken care of automatically. We can see that the length of the learning curve will be 150 metres, a bit longer than we wanted, and the average production rate over the whole curve is 10 metres per day. We can adjust the length of the learning curve a little by changing the start production rate. If we try a start rate of 0, that reduces the average rate to 9 metres per day, and also decreases the learning curve length to 135 metres. We might decide that this curve is fine and want to use it. If, however, we want to have the length as exactly 125 metres, we need to use the other method of variable acceleration. So let's try that method. we select the variable acceleration method. This method allows us to enter an end chainage for the curve, so we will put in 125 meters. As can be seen, we can have the exact length that we want, and this gives an average production rate of 8.33 meters per day. Let's put in a start production rate of 2 meters per day. That seems okay, we will go with this curve. With the variable acceleration method, we do have to be a bit careful. If we enter an inappropriate parameter, say an end production rate of 3 meters per day, we get strange results. In this case, a reverse S-curve. We can use this figure, but we would need to adjust the distance and or the duration. We will put the end rate back to 18 meters per day. The learning curve will be generated in the form of activities in the planned form. All planned activities need to be allocated a work breakdown structure value and a calendar. I have already created a work breakdown structure, so we will select a value from the WBS drop-down list. This curve will be for Tunnel B drive. I have also created some calendars so we can select the one we want from the calendars drop-down list. We will select the 7-day week with site holidays calendar. The description will be given to all of the learning curve activities. By default it is LC for learning curve, but you can change it if you want. We will leave it as LC. The duration of each activity determines how many planned tasks are created. By default the duration is 1 day, so for this example 15 activities will be produced. If we want fewer activities, we put in an appropriate activity duration. Let's put in 3 days, then we will have 5 activities. The curve is still distinct, as you can see from the chart. We can now generate the learning curve. To do this, we click on the Create button. We get a confirmation message and we select Yes. We can now close the dialog and continue with our schedule. We don't see anything in the main chart yet, we still have some work to do. To do this, we will go to the Plan form. From the toolbar, we click on the Plan button to open the Plan form. We can see the 5 activities generated by the Learning Curve tool. They are all linked together with finish to start relationships, but as you can see from the start dates, no scheduling has happened yet. We need to add the full production element of the work still, so we will add a new activity by clicking in the last task and pressing the down arrow key on the keyboard. We'll call this activity full production. And the chainage range will be from 125 meters to 300 meters. We set the production rate to 18 meters per day and then link it to our learning curve by adding a predecessor, in this case to activity 5. The default relationship of box finish to start is fine. For lines, it is exactly the same as the finish to start relationship. If we already had other activities in our project, we would add a predecessor to activity 1 and a successor to activity 6. However, for this demonstration, these are the only tasks, so we can't do that. All that is left is to schedule the program by clicking on the Schedule button in the toolbar. And then we can exit the form to view the chart. We now have the full tunnel drive, including a learning curve. Now this is not a tool you will need every day, but when you do want it, it's nice to know it's there and how to use it. Anyway, I hope you found this video helpful. See you in the next video. TimeChainage, adding an extra dimension to your schedules.